Today's class, we will be discussing sorting in data structures. So what is sorting? The process of rearranging the given elements so that they are in ascending or descending order. That is known as sorting. That is, for example, I will give a set of elements which are in random. I give set of elements which are randomly arranged. You need to sort them. That is, you need to arrange them properly. For example, I'll give 4, 2, 1, 3, 7, 8, 6, like this. So some set of numbers will be there. They will be randomly arranged. They won't be they won't be in either increasing order or decreasing order. We need to arrange them. We need to rearrange the elements properly. Now, for example, I'll rearrange this element in increasing order. Increasing order. When you take this in increasing order, what you'll get? 1, 2, 3, 4, 6, 7, 8. So this now I have arranged the elements in increasing order. This arranging, the process of arranging a given elements either in increasing or decreasing order is known as sorting. Okay, this is, for example, they have given this example. Look here, I have taken one simple example. Suppose an array contains 10 elements, 7, 8, 4, 6, 8, 1, 2, 17, 14. These are randomly arranged. Now I have to arrange them in an ascending order. I will arrange like this. Or you can arrange them in descending order, where 17 will be the largest. It will come first, 14, 9, 8, 7, 6, 4. So this type of arranging the elements either in increasing order or in decreasing order is known as sorting. So when you come to this sorting, when you come to this different types of sortings, we have various sorting techniques. That is, we have merge sort, we have insertion sort, we have bubble sort, heap sort. Different sorting techniques are there, which we will be using as an algorithms or programs to sort a set of elements. So among them, in our data structures, we will be studying about very important sorting technique that is known as bubble sort. Okay, so what is this bubble sort? Now we will see what is this bubble sort, what is the basic important logic involved in this bubble sort, and what will be the program for this bubble sort. So first we will see the definition of bubble sort, then we will go with some example. Most widely used simple sorting technique is bubble sort. This technique sorts the array by repeatedly moving the largest element to the highest index position of an array. This is very important. This technique where it will bubble the largest element or it will move the largest element to the last that is to the last position or to the last index of an array. For example, I have 8, 4 and 6 for this example. For example, this is an element. This is the set of an array. What this bubble sort will do, it will bring this to the largest, that the largest element will be at the last. It will bring to the last. Like this only we will be doing. So we will move the largest element to the last and then we will see through the logic later. This is what it will just move the largest, repeatedly moving the largest element. One element I have moved again and again, next set of elements we will move again some set of elements. We will be sorting such that we will get them either in ascending or descending order. Okay, that is known as bubble sort, especially we do for ascending order. In this technique, each element is compared with its adjacent element. So to move the largest element to the last position, first what we have to do, we have to compare the adjacent elements. First we need to compare the adjacent elements. The first, when we are comparing the adjacent element, if the first element is larger than the second one, then the position of an element is interchanged, otherwise it is not changed. This is what the main important logic in bubble sort. First it will see the elements. What it will do, it will compare the first two elements. If the two elements where if the first one is larger or the second one is smaller, it will swap. Now for example, if I take 8 and 4, 4 is smallest, so 4 will come first and 8 will go there. 6 will be like this only. Now I have swapped only 2 elements. Like this, it will repeat till the last element. Okay, and this the name itself tells you bubble, that is bubbling. Highest will go to the bottom and bubbles will come, bubbles will be there, so that the least elements will float on the surface, the largest element will sink. Okay, that is known as this bubble sort. So next one iteration, what happens now? These two elements are compared. Now again, these two elements will be compared next. In this elements, you check whether 6 and 8. If the largest element is at this position, it is okay. If it is not there, you have to swap it. Again, it will swap and you will bring this element like this. Till you will get a set of elements, this will be repeated process until you get a last element which are all neatly arranged in a proper order. Okay, during the next element is compared with its adjacent element and the same process is repeated for all the elements in an array. During the second pass, the second largest element occupies the second last position. Okay, so this is very less elements I have taken. So this is first thing in this first pass itself. The passes I'll tell you what is the pass and all. So in this, what it is doing, just comparing the elements, swapping, then again comparing the next to swapping. So during the second pass, the second largest element occupies the second last position. If many elements are there, second largest element, first largest element will come at the last second largest element. That is, for example, if it is n, next largest element will be n minus 1, that will be n minus 2, like this it will come. The same process will be repeated until all the elements occupy their proper sorted position. This is what the main important logic of bubble sort. Now we will take a simple example for this bubble sort. We will see how this sorting works with the help of basic logic, whichever now I have explained. Then we will go with the. So first we will go with a simple example for this bubble sort. Now I have a simple array. We will take with a simple array where n is equals to 5, 0, 1, 2, 3 and 4. Indexing is always starting from 0. I will take 15, 16, 6, 8 and 5. Okay. Now we will go with this sorting technique. Now n is equals to 5. So what we have to do? First we have to compare the first element with the next element. That is, I'll write the elements like this: 15, 16, 6, 8, 5. So the first step is compare the first two elements. If the first two elements after comparison, the first element is smaller than the largest, or the first element is largest than the second element, you need to swap it. Now 15 is smaller than 16, so no need to swap. So write as it is. Write as it is. Now we have to compare these two elements, second and third. This is a repetitive process. So second and third is compared. Now check whether 16 is larger than 6. If it is larger than 6, you have to swap. Swapping is nothing but introducing the numbers. So now 16, 8, 5. Now again compare these two. So it is 15, 6. 16 is larger than 8. So bring 16 to the next position and bring 8 to the first position. Now again move to compare these two elements. 15, 6, 8, 16 is larger. So swap 5 and 16. So now look here, as I told, the largest element comes to the last position in the array. So when the largest element comes to the last position in an array, you will stop the process here. That is, this says first pass. This says first pass. So when the largest element comes to the last item, last element, it becomes the last element in an array. That is, you have completed with first pass. Okay, now we have to take this elements. We have to take this one, this as an input to the next thing, and we have to repeat the same process again. So I'll take 15, 6, 8, 5 and 16. Now repeat the same process. Now compare 15 and 6. So I will swap this 6, 15, 8, 5 and 16. Now compare these two. 6, 8 has to be swapped because 8 is lesser than 15, 5 and 16. Next, compare these two. So I'll get 6, 8, 5, 15 and 16. Now look here, 16 is larger. Next largest element has come to the n minus 1 position. That is, before the largest, the 15 has been stopped. So this where you will stop. Now again try to compare these two. You cannot do because these are already in a sorted order. So this comes with this ends the second pass. This is the iteration. Pass is also known as iteration. So this is pass 2. So now we have to take this as a element for the next pass. We have to take this as an input for the next pass. That is 6, 8, 5, 15 and 16. So now compare these two. So now 6 is lesser than 8. No need to swap. So write as it is. Now what you have to do, you have to compare the second and third element. So when you compare 5 is smaller, bring it, that is swap it and write the next remaining elements. So now compare the next element because 15 and 16 are no needed to swap because they are already in a sorted order. Now 8 with 15, yes. 8 with 15, 8 is smaller than 15, no need to swap. Now 8 is the next largest element which is after 15, that is n minus 2. Now you see this, these three are in the sorted order, 8, 15 and 16, they are in a sorted order. So you should stop here. This is the third pass. Now we have to take this, we have to go with this input and we have to start 6, 5, 8, 15 and 16. So now we have to compare these two elements. When you compare these two elements, five is smaller than 6, so we need to swap 5, 6, 8, 15 and 16. So now we have to check this, check whether we need to swap these two. No, because it is already swapped. Again, you can, if you want, you can write the same process still this is how many rows, how many columns you have. Look here, this is first 1, 2, 3, 4, 5. At fifth I got this. So you can repeat till 5 different columns, but for understanding purpose I'll stop this here itself. So now you need to swap this. So swap it, no need. Again, for example, I'll write the same thing, 6, 8, 15, 16. So these are all in sorted order. Now again, check this. No need to do this. 5, 6, 8, 15, 16. You need to swap these two. No need. Look here, already we got a array which is already sorted. So this is last pass. Pass 4. That is fourth pass. So now how many elements were there? N was 5. So number of passes is 4. Always in a bubble sort, always remember number of passes will be n minus 1. So now look here, 5 number of elements are there. So totally we are done with 4 passes. That is 5 minus 1 equals to 4. 4 passes, we will get the output which is a sorted order. Okay, now this is what the basic important logic of bubble sort. Now we will try to write a code for this so that the basic logic will be written as a code. Now look here, I have arranged these elements in a order 15, 16, 8, 6. Now what I am doing, I am repeating the process. I am comparing 15 and 16, then 16 to 6, 16 to 8, 16 to 5, and finally I'll get this. So first what I have to do, I have to start with one iteration, right? Where I am taking this, I have to start with one iteration, then I should repeat the process again and again. I should repeat these elements or I should repeat the processing again and again. Okay. So what happens now? For this first step, for initially I am telling this as passes. So for passes, we have to consider one for statement. That is, this is entirely one pass. Then I am taking the output of first and I am going to the second pass. I will do the repeat the same process again and again. Third pass, again fourth pass. So whatever the passes you take, even though whatever the passes you take, the processing is same in all the passes. So to interchange elements, I want one for statement. For passing, I want one for statement. So what is that? I'll write for, I will take I and j. I is as row and j is for column. Okay. For I equals to 0, I less than n minus 1. Look here. Why n minus 1? How many number of passes are there? There are n minus 1 passes. So for this purposes, for this for statement is for number of passes to enter into the loop. So n minus 1 I am taking I plus plus. Now what happens? Now after entering into this, I need to swap each and every element. After once I enter into this, I have to swap. So for swapping, I'll write one more for statement for j equals to 0, j less than n minus 1, j plus plus. Why? Because look here, here also same thing. Till we will swap until this, once the largest element comes to n, we will swap till only n minus 1 location, right? We'll swap only till n minus 1. So I'm writing it as j is less than n minus 1. I'll tell you this again, this for statement is little bit incomplete. We will see how to complete this again. So this is the logic. So this for statement is for passing, for iterations. This for statement is for swapping. So now what I'll do to check, to swap the conditions, to swap the elements, what do we have to do? We have to check whether the first element is greater or smaller than the second element, right? So what I have to do? I have to write one if statement. So if I'm taking it as an array because these are all arrays only, right? These are all arrays. This is a two-dimensional array, one column. So I'm taking it as an array. So now this here I'll take it as a one dimensional because I'll complete only this row and then I will go with this row. So now if a of j, because comparing only with j, j is only for swapping, I is only for passing. A of j is greater than a of j plus 1. So what we did, look here, we are taking this as a of j and we are comparing this with a of j plus 1. So now we have to compare if it is larger. If it is larger, for example, now you take here, you look here, 15 and 16. We didn't compare. Now we will come here. I have to come here. I have to compare this. If it is larger than this, what we have to do? We have to swap the elements. So to swap the elements, we have already, we know this. We will take one temporary element. Temp is equals to a of j. Then a of j is equals to a of j plus 1. We have to swap this. Then j plus 1 is 10. So this is what important logic to swap the items. Now we will trace this. We will trace with this with a simple example I will take and we will trace this. For example, now look here, I is equals to 0. I is less than 5 minus 1, 4. The condition is true. Since the condition is true, now we are taking this row and we have to swap this first. We will enter into the swapping statement. Now, for j equals to 0, j less than n minus 1, j plus plus. So, j is equals to 0, j is less than 4. The condition is true. Now, look here. What is this? If a of j is greater than a of j plus 1, 1. A of j is 0. A of j plus 1. What is a of 0? This one. I'll take this as 0, this as 1, 2, 3 and 4. So a of 0 is 15. Is 15 greater than 16? The condition is false. If it is false, swap. Else, what we have to go back to the for statement, increase the value of j by 1. So again, j is incremented by 1. So j is equals to 1, 1 is less than 4. Yes, the condition is true. So now again, if a of j is 1, 1 is greater than a of 2. What is a of 1? 1 is 16. Is 16 greater than 6? Yes, the condition is true. So now you have to swap this, enter into this. So temp is equals to 16, then 16 is equals to 6. Then what is this? A of j plus 1. That is A of 2 is equals to 16. Whatever the temp element that will come. This is what swapping occurs. Now I am doing swapping. So A of 2 is equals to 16. So now look here. I have swapped. I have brought 16 to A of 2. This is second. This is 0, 1, 2, 3, 4, 3, 4. These are indexing. So in second position, I have brought 16. Again, increment the value of j by 1. So now compare these two, swap these two. Now again go back. Now I will increase to 4. So 4 is less than 4. The condition is false. It will come out. This is what I have done. Finally, we will swap the number of elements. So this is what we have done. So now look here. I have each phases. I have skipped one step. For example, now when you take this phase, first phase, 1, 2, 3, 4, 5. So 5 different rows are there. So number of rows are 5. When you come to this next position, for example, I'll take this as I is equals to 0 because I have written this as passing. I'll start with 0. This first pass is 0. Second pass is I is equals to 1. Third pass, I is equals to 2. Last pass, I is equals to 3. So now when I is equals to 0, how many number of rows were there? 5. When I is equals to 1, how many number of rows are there? Number of rows is 4. When I is equals to 2, number of rows is 3. When I is equals to 3, exactly here I got it. Number of rows is equals to 2. Look here. As the number of I, that is iterations I are increasing, number of rows are reducing. Right? So, if I take this for statement, I have to repeatedly do again and again. Now I have written R is equals to 4. This is enough. I need not to swap this. If I write the inner for statement, if I just write like this, again I have to write 6, 8, 5, 15 and 16 like this. Here also same thing. Again 2 steps I have to write. Here also again 2 steps I have to write. So number of timing and memory will be wasted. So what I have to do, number of passes, in number of passes, number of steps I can stop. So here what I have to do, I have to write this as Jn minus 1 minus I. So if you write n minus I, the number of rows whichever you are doing, the operations will be reduced. So this is a par statement for j equals to 0, j less than n minus 1 minus I, j plus plus. Once this iteration is completed, this will stop. Once this iteration stops, again we have to go to the next par statement, that is increment value of I is equals to 1, 1 is less than 4. Now you will come to this pass, I equals to 1. Again repeat the same process, second for statement. Go to the second for statement, repeat this process until you get the swapped items, that is 2 elements will be swapped. Now after this, J will be, you will reach a condition where you cannot swap, that is you will stop the second pass, again go back to the before, that is go back to the outer for statement. Now increment the value of I by 1, I will become 2, that is you will get this pass, you will get this third pass. Again repeat the process, just come to the inner for loop, repeat the process once, again go to the outer for loop, when I will be 3, repeat the process, you will get this condition where you will stop, you will come to this for statement, you will swap all the elements and you will go back both for statements, the condition will be failed. You will reach a condition where you cannot enter both the for statements. At that time, you will be getting the sorted array and you can print this sorted array on the screen just using a for statement. That is a simple for statement and printf statement, because since we are using an arrays. So this is how the bubble sort technique will work. Thank you.